Vijay Karunamurthy was a director of engineering and machine learning at Apple and at Google, where he worked on applications for AI and personalizing human interfaces. He's now the Field Chief Technology Officer for Scale AI, where he partners with large model providers, governments, and Fortune 500 companies to solve AI's data problem. That's what he's going to be talking about today. He's going to be talking about the raw material fueling AI, which is, of course, your data. Please give Vijay a warm welcome to Doha.
Thank you, John, and thank you to World Summit AI for an amazing, insightful 2 days of speakers and panelists. You just heard on the panel right before me Samir say much more plainly than I ever could say that AI is data. So I'm going to build on that concept and take it up a little bit to a higher level and talk about the strategic value that data plays today in building this technology. Now, I think you've also heard that AI is maybe one of the most transformative technologies that have ever been created, on par with the development of the mobile phone, on par with the development of the internet and sharing through platforms like YouTube. I'm very excited about the potential of this technology, but underpinning all of it is data as the foundational layer of how we build AI. And I'm going to talk about the role that data plays in making more trustworthy AI systems, the role that AI plays in defining governance and risk as we develop this technology in a responsible way, and the role that AI plays in human oversight, and the role that experts and humans play in developing this technology in a reliable and safe manner. We're one of the leaders in developing all of those threads, and so I'm going to talk about the frameworks that we've built in order to help data be used to build the future of this technology. So to start with, this is the 3 pillars of AI development that are important today, and we're going to talk about the strategic consequences of each one of those. So first, on the left-hand side, you've heard a lot about the hardware side of the equation, the GPU chips that are used to train and run today's large models. The value of those chips can't be understated. They're a limited resource, and those that are able to acquire a large number of chips are able to change the future of this technology. On the right-hand side, you have the algorithms, and this is where the role of machine learning researchers and the world's top talent in AI play in developing the future of new models, new techniques to harness those models, and in the future is going to be the ability to build agent-based systems that leverage multiple models together to give more reliable or more trustworthy answers than any single model could alone. But underpinning both of those is data. And data comes in many different flavors and forms, but without it, you can't leverage the power of the hardware or the power of the talent, the human capacity that you have to train AI models. And you're really starved for those 2 resources if you don't have the middle resource to train your models. Data can come in a variety of different formats, and we're going to talk about the role of both training data and the role that data plays in evaluating models, so we know when new model capabilities come online, what they actually are capable of achieving, and how humans can leverage those models in order to build more reliable organizations or more capable, more efficient ways of addressing really important needs across humanity. First of all, I want to talk a little bit about the role that scale has played in defining the value of data and proving to everyone that data is the most important resource in training AI models. We really started in the early days of the AI revolution, where computer vision models were being harnessed to build self-driving vehicles. And in that domain, the role that data played became a quickly important resource for every company that was starting to train self-driving cars. We realized early on that the value of even a couple of frames of data showing a particular incident with a pedestrian on a crosswalk, maybe walking a bicycle across that crosswalk, could be worth its weight in gold in getting a model to reach a certain safety milestone that a car manufacturer or a self-driving vehicle startup needed in order to get fleets onto the road. And so we built models and the ability to use humans in the loop to help you find those needle in the haystack moments that can help you train more sophisticated AI models and keep pushing the technology forward. Now, it turned out that played a really key role in the future of AI across many different industries and sectors. And we also started to build some really important public-private partnerships. So we started partnering with the US government and various agencies, including the Department of Defense, on using AI models in order to address long-standing challenges with dealing with new information and sources of information that needed to be used in a reliable, timely fashion. Now, it just so turned out in 2021, a new phase of this technology was emerging. And we played a really key role here with some of our partners on training what are called frontier models. I'm going to explain in a moment what that means, what actually makes a model a frontier model. But in this era, it really became development of pipelines that could be used to create models that human beings could actually use. And we first saw this with the release of ChatGPT in 2022. Several data pipelines that we set up with OpenAI researchers helped move that technology forward such that anyone could use ChatGPT and ask a question and understand how to leverage this technology in order to do real-world tasks. And that really set the doors open for a variety of different industry use cases, which we've only just started to see emerge over the last couple of years. Really where we are right now is in this phase where we're just accelerating development of new AI applications. And that means that we're leveraging a lot of partnerships across the compute layer, the model development layer, and now the data layer in order to accelerate how those AI applications can be brought to be used by human beings in the real world. At the core level of how these models are trained, they are the data that was used in order to create the models. And one way in which we're seeing this emerge is by understanding where the models fall apart. So whenever we look at a new model and we see a new model that's been trained by a research lab, we try to find areas where that model does better than human beings and areas where the model might be underperforming. And one example of underperforming could be what's called a hallucination, where the model gives an incorrect answer seemingly out of nowhere in response to a human question. So one way in which we know data plays a key role in how those models are trained is that when you find a hallucination in one model trained by one lab, and you go and look at a variety of other models trained by other labs, you sometimes see the same pattern emerge in models that were trained in entirely different parts of the world, by entirely different teams of researchers, sometimes on entirely different model architectures. And the reason for that is that the underlying data behind the models actually informed how those models thought about your question, how it framed the answer, and what sources of information it used in order to get the answer to your question. So we're pushing forward research in order to get much more dramatic improvements on model accuracy, having models that avoid hallucinations in the first place, as well as systems put in place to help leverage that data so that the answers can be accurate and reliable the first time, and humans can also exert oversight over how those answers are used. Now, how we're seeing this technology used also defines the strategic role that data plays. So on the left-hand side of this chart, you can see the frontier model developers, those that are able to push this technology forward and define how it can be used in brand new domains that we haven't tried it out yet. Now, in the history of this technology, we saw text being used as a modality that was the most important back in 2022. But now, increasingly, models are coming out that are multimodal by default. They're able to use voice and access voice transcripts. They're able to leverage image generation capabilities. They're actually able to write and execute code in the background on your behalf without you ever asking the model to do that for you. So these new capabilities are emergent as the models are trained and as they leverage new data sources in their training routines. And we think it's very important to get ahead of what those capabilities mean as these models are deployed. In the middle bar, you could see the sort of private sector partnerships that we've built in order to push this technology forward in a couple of domains. And some that are really important for all of us are how AI is going to be used in education. We have a great partnership with Chegg in the US on defining new models that can help learners on their journey through college or through university. How it can be used in real estate, how it can be used in solving really difficult problems in the financial sector, and defining new efficiencies in that sector so we can better serve a wide range of customers. We're just pushing the technology forward today, and we're going to see brand new use cases emerge over the course of the next few years. On the government side of the equation, we're also seeing these models used in order to find citizen services, help solve longstanding national security problems, stay ahead of emerging threats, and we're really excited about pushing new opportunities for agents in the field to leverage this technology and really trust in the model outputs when they ask for information on a really fast-moving threat or an opportunity to improve efficiencies in a supply chain or a difficult logistics problem. This is just an example of some of the partnerships that we've done where data was the underpinning layer that defined how we push this technology forward. So I mentioned our work with OpenAI. We also worked with them on fine-tuning some of the newer model releases that they've had. And as open source models have been released, for example, Meta's family of Llama models, we've figured out ways to use that data in order to further fine-tune those open source models, sometimes in a private, secure fashion, so that you can leverage data that needs to be kept secure by default. We've also worked with Microsoft and large cloud providers, and increasingly we're starting to see these strategic partnerships at the cloud provider level become important for the responsible deployment of these models. Because you can leverage data that's being kept secure in an AWS facility or a Microsoft facility. You can ensure that that security is kept all the way forward as you fine-tune a model and build out an application end to end. Really where we see the value chain happening today is the ability to build custom full-stack GenAI applications. And that starts by really clearly defining and scoping the use cases that this technology is going to be used for. in order for you to understand what a responsible deployment of Gen AI looks like. So a given use case may be tackling operational efficiencies in the financial services sector. It may be tackling fraud and KYC regulations or other things that are really emerging threats for any sort of financial services firm. But once you scope out the use case, you can understand the custom application that needs to be built for that use case and what sort of thresholds you have in order to responsibly deploy that application. So we really start by thinking through the use case and thinking through the evaluations that'll set us up for success over 3 months or 6 months of development in order to ensure that that use case gets out the door into the hands of employees or customers. Those are actually going to see the impact of the model, rather than jumping ahead to the conclusion that this technology can be deployed day one, which in many cases it can't until you define the data side of the equation. Now, I get asked a lot now because there have been a couple of articles that have been written about the data wall that's emerging with AI. And really what people are asking is whether we've hit a limit on the capabilities of AI models because there isn't a lot more data that's out there on the internet in order to train the next generation of models. And it's very true. A lot of the models that have been trained over the last year have relied upon a lot of public data that's available on the internet. Much of which is in English, much of it is in common coding languages, but that data is shared commonly across almost every large model that's trained today. We have probably reached the limit of what data is out there available at around 1 trillion to 5 trillion tokens of data. Token is a term used to define one unit of data that you've gotten from a sentence or a paragraph of text. But what you can see here, if you think about that public data as the pink circle, the small pink circle you see on the left, there's actually a treasure trove of data that exists within governments and within the private sector that isn't being used to train these large models today. And the reason for that is these are private data on citizens, on employees, on customer service interactions, data that will always need to be kept private within enterprises and can't be used to train publicly accessible models. So the routine that we're seeing becoming increasingly important today is finding the ability to leverage the value of that data and train models or fine-tune models or build systems around that data so that you get the value of all of that internal knowledge that you have as an organization or that you've built up as a government over time and use that in order to better create citizen services or better opportunities to upskill your employees and leverage this technology in new ways. At the bottom, what you get is differentiated IP and the real return on investment that you get from this technology, where you've used all of that private data that you've assembled, that knowledge that you've assembled over years, and you've trained something that's really unique and differentiated on top of it. At the end of the day, we really think that there's a data edge that's underappreciated that enterprises and governments have to leverage, and that they're going to have to use that in order to further use this technology. Now, if this enterprise data is about 10 times the size of the total publicly available data that's on the internet, we're going to start to move from models that are just powerful generalist models that are able to answer those questions that people could using that public data to models that are specialized and have certain expertise in areas that governments and enterprises need. So you can imagine a model that's trained to look at building permit regulations. That model just needs to be an expert in that one particular domain. It needs to leverage all of this human capacity that you have in an organization to address questions about this particular area and do that reliably using multimodal inputs or using legal reasoning over time, all sorts of opportunities to leverage that in order to tackle that particular area. We're starting to see this across the board in real estate and financial services. People understand the value of the experts that they have internally and what sort of knowledge transfer that they're doing today, and they're hooking in the models into that internal human network of knowledge so that the models can better answer these questions. Now, when you do this successfully, you should be seeing not just a straight line of how you do model development, but really it's a circle and what we call the data flywheel of how you do model training. And we've spent a long time talking about optimization as a loop and not just a straight line. And this is that laid out as a fact for Gen AI as well. When you start off thinking about how you're going to improve your application, really you immediately start thinking about what's the right way in which I evaluate how my models are performing today. How do I know where the models are giving accurate answers and where the models might be giving a hallucination or might be misleading a human expert that's trying to leverage that model output? So evaluations are really the name of the game in understanding where you stand today. And then if you get further investment in production monitoring, you can understand how your human experts and users are using those models, where they might be making mistakes in evaluating the model outputs, and what areas do they want to push your model forward? Where are they asking questions that you know you can't answer today, and how can you build in the data in order to make that possible? And really, we transfer all of that knowledge back into data generation. This can come from a variety of different sources, but we try to find the most impactful data that will be used to push this model forward in the future. So you're not shooting in the dark and trying to find thousands of documents that can answer this question, but you're trying to find maybe one or two that give the best possible example of a model leveraging internal resources and using that to create a more reliable output. Now, we've pushed this field forward, and we've shared a lot of our work publicly as well. Over the course of the last year, we've created what we call our Safety Evaluations and Alignment Lab within Scale. And this publishes the world's best benchmarks of how models perform today across a variety of different domains, including how newer agent-based models answer questions about financial services or economics questions, so we can understand where the frontier is with the models that we're seeing today. We also work at the US government, for example, the Chief Digital and Artificial Intelligence Office, assessing use cases of Gen AI across the entire Defense Department, as well as other agencies, so that folks in the field can use this technology in a reliable and trustworthy fashion. And what we've seen is that as you move from just building the models to actually entering this loop of evaluating and improving the models, you get tons of benefits in how you build AI into your existing frameworks and your existing patterns of how you do governance and risk management. You get a lower total cost of ownership because you're customizing your own models and you're amortizing that upfront investment of fine-tuning a model over many, many life cycles of how that model can be further trained and deployed. And you get full visibility and control over how these models are used, including the human oversight layer that you might need in order to ensure that models are being used in a way that's free of bias or free of misinformation, other sorts of risks that can come up depending upon the use case of how you're deploying AI. Now, what I'm really excited about today and where we're pushing things forward, especially in this region, is really understanding ways in which this proprietary data can be leveraged to build leadership. And so we're seeing a variety of different use cases where we can push the technology forward. And some of the most important ones involve internal knowledge management and the ability to leverage a lot of internal resources that we have in the organizations we work with. Some of it's automating processes that are long-standing, difficult processes to improve efficiency on. But lastly, one of the most important areas that we really are excited about tackling is having models that work better in Arabic and local languages so that you can have better human oversight, better expert interaction with these models, be able to answer questions in a legal domain or in another privileged domain, and be able to do that reliably so that speakers around the region can use these models credibly. We're really excited about pushing this technology forward, but it has to be done in partnership with human beings that are using it. And so we're learning a lot as we deploy out these use cases, what further model improvements can help make that collaboration work a lot better than just trusting the model outputs alone. So with that, I'm really excited about the future of the next couple of years. We've seen a lot of regional leadership take place over the course of this year, and we're really excited about the future of these partnerships going forward. And I think we have a couple of minutes for some questions, if folks have any questions in the audience.
Round of applause, please. Can we get a microphone to this gentleman here, please? Raise your hand nice and high if you have any questions for Vijay, please. Thank you. If we can have the monitor on the stage, thank you.
Thank you. My name is Walid. I'm curious to know, a gentleman in a previous panel mentioned that it is very challenging to get data, especially from army and such things. So how can you convince those entities like the Air Force and maybe the Army to provide you with content which is critically sensitive?
Yeah.
Are you owned by a government entity or what exactly? How can you do this?
Well, let me tell you first the one thing we don't try to convince people. We never try to convince people you should move data from a secure environment where you have proper data governance in place to an unsecure environment where you suddenly are going to lose control of that data. And one of the ways in which this technology is transformative is that you can move the models and you can move a lot of security infrastructure to where the data is located, where you already have those security controls in place. You can operate on the data in a secure manner. You can use experts that are qualified to evaluate that data in a secure fashion to evaluate the models themselves. And that's the mindset in which we operate. We don't try to get access to the data in a way that's going to compromise the security or the privacy of what's stored there. But whenever we're working with citizen data, where that could be stuff on what's called PII, personally identifiable information, we always try to make sure we move the AI to where the data is stored, and we test for the security of the AI before we do that deployment, so that you're never compromising on the integrity of the original data that's there.
How portable are these really large systems? When you say move the AI, we heard HP saying the same thing. Mm-hmm. we'll just stick these LLMs. How portable is something like a very powerful LLM?
Yeah, that's a great question. The very largest models are absolutely not very portable. Those models need to be deployed at the largest data centers in the world. Only a few of them can run at any given time. But we often have seen a lot of value in distilling down the insights from those larger models into what are called smaller models, SLMs, sometimes small language models. And those can be deployed in a really sophisticated fashion where the data is stored. Sometimes multiple models working together can give you a more reliable answer than just one large model could on its own. And so we're seeing that pattern become really important.
I presume the cleaner the data, the better managed the data, the less of an LLM implementation you require. Would that be right?
Yeah, that's absolutely right. The quality of the data is incredibly important. And even though there's a huge amount of data publicly available on the internet, a lot of that data contains factual errors, misinformation. Filtering that down to just factual statements about medical questions or legal questions is an important part of how these models are trained. And we see that value playing out as you further train and fine-tune models too.
And in terms of language and unstructured data, that as well obviously requires a little bit of extra compute versus just numbers. I mean, sometimes you may not even require an LLM at all if we're just dealing with stats, right?
Yeah, we're just learning that now, that the value of working with images, even if they're charts and graphs, can be much more powerful than just working with text or numbers alone. Sometimes if you ask a question about an economic trend to a model, instead of just passing in a chart of numbers of stock market performance, you pass in an image of the chart of how the stock market's trended over time. The model can suddenly answer all these questions for you that it wasn't able to answer with numbers alone. So we're learning a lot of things about what multimodal data actually means for the sophistication of these models and what questions they can ask.
When you're trying to visualize some of these, if you're working with a large amount, you're trying to visualize a large amount of data, are you finding that is an easy thing to do with LLMs? Or because a lot of the models that I see out there, it's quite difficult to visualize data. So if you're speaking to partners or trying to demonstrate the product, do you find it's easy to get good visualizations of data?
Yeah,
it's slightly off topic, but actually I thought you might
No,
know.
it's exactly on topic. We published some research on this, actually. There are really increasingly sophisticated ways where you can think about human conversations or speech or language and try to visualize the patterns of how you see people talk so that you can pinpoint areas where you have a lot of high-quality data, maybe areas where you are underperforming your data. For example, maybe in some customer support interactions, you give very factual information to a customer. In other cases, you're trying to be really creative and you're trying to be funny and interesting. You can actually pinpoint that you're missing some examples of that and use that to further train your chatbot.
Very, very quickly, because we are out of time. This gentleman here with the microphone, go ahead.
Okay, hi. Thank you for the great content and the stellar delivery. I have a quick question regarding inbreeding, training AI on contents produced by AI. I believe now it's regarded as a bug. Could it be a feature down the road?
It is a danger. I think it's something that we know. We don't yet know how dangerous it is, but we do know that when you train a model on its own outputs, sometimes you see really interesting, weird behavior that's hard to explain. So there is a lot of value in what's called synthetic data in certain domains, and we've harnessed this a lot. For example, financial questions, you can generate a lot of synthetic data, helps the model understand how to structure its thinking about those questions. But it's important to be careful. You don't want to impact the creativity or the underlying reasoning of the model just by relying upon the outputs of another model rather than real human feedback.
Yeah, it reminds me of just that, the lack of clarity as you carbon copy something over and over again. You're going to lose that resolution. Wonderful. Thank you so much for joining us and teaching us a little bit about these large-scale models and how they interact with some of the world's biggest companies. Please put your hands together for Vijay Karunamurthy.
Thank you. Thanks so much.